So good evening to one and all. Now we discuss about the design of FIR filters using windowing techniques. Okay, when we observe the Fourier series method of designing of FIR filters, there is a Gibbs oscillations are introduced in the pass band and stop band of the any filter. So to overcome that one or to remove those Gibbs oscillations in the Fourier series method, we go for windowing techniques. In the windowing techniques, step 1 is choose the desired frequency response HD of e power j omega for a mentioned filter such as low pass filter or high pass filter, band pass or band stop filter. I think all of you know these ideal or desired frequency response of the low pass filter for a given cutoff frequency, as well as a high pass filter for a given cutoff frequency, band pass filter and band stop filter. Next, step 2, find the impulse response HD of n by applying the inverse DTFT, that is HD of n is equal to 1 by 2 pi integral minus pi to pi HD of e power j omega into e power j omega n into d omega. After applying the inverse DTFT, we obtain the infinite number of samples HD of n. But we require the finite number of samples. For this purpose, in Fourier series method, we apply the truncation process. Due to that truncation process, Gibbs oscillations are introduced in the pass band and stop band of the filter. So to overcome that problem, here how we get the finite impulse response h of n, simply by multiplying the infinite sequence HD of n with finite length window sequence W of n. That is h of n is equal to HD of n into W of n in the interval of minus of n minus 1 by 2 to n minus 1 by 2. And also we can assume that here h of minus n is equal to h of n. So next, step 4, determine the causal FIR filter transfer function h of z by applying the z transformation. H n of z is equal to h of 0 plus summation n is equal to minus of n minus 1 by 2 to n minus 1 by 2 h of n into z power minus n plus z power minus n into z power plus n, h of minus n into z power n. So by using this formula, you can calculate the non-causal FIR filter transfer function, which is not a physically realizable or not implemented due to the positive powers of z. So we need to convert the positive powers of z into negative powers of z simply by applying the multiply the hn of z with z power minus of n minus 1 by 2. That is a step 5. Determine the physically realizable system or causal digital filter transfer function h of z is equal to z power minus of n minus 1 by 2 into hn of z. Okay. So after completion of this step, we get the physically realizable system transfer function of the given FIR filter, either it is a low pass or high pass or band pass or band stop. Then we can realize or implement that FIR filter using either direct form structure or linear phase realization. So how to identify whether it is a linear phase or not? Simply you have to check h of n is equal to h of n minus 1 minus n or not. If h of n samples are satisfying this condition, then we can conclude that our FIR system having linear phase. So if it is having linear phase, then we can apply the linear phase realization technique to implement or realize that h of z for a given FIR filter. And finally, the last step in the designing process is choose the proper frequency response from the frequency response of FIR filters concept. Find or draw the magnitude and phase responses for various values of omega, where the magnitude and phase responses of the given FIR filter can be determined or can be decided by depending upon the value of n, either it is a even or odd, and symmetrical response of the given filter, either it is a symmetrical or asymmetrical. So like that, if for n is equal to odd and symmetrical, one type of response, for n is equal to even symmetrical, another type of response, like that one. So after that we can substitute the various values of omega in the interval of minus pi to pi. We can draw the magnitude and phase response of the for various values of omega. This is the procedure for finding the or design the digital FIR filter using window method. Thank you.